Hi everyone, it's Kenneth Ramirez, and this video is going to be going over my Discharge Lab experiment. As an introduction, the goal of this lab was to visit a real stream for my group and take measurements of width, length, and depth and the travel time of our flotation device, which was a fishing bobber. In this picture you can see I'm measuring the length of a section of the stream. The controlled variable in the experiment is the depth, because the depth remained constant at an average, and the width was the variable that we chose to change, and the velocity was the dependent variable, which changed based on width. For methods, I measured distance and width with a long roll-up tape measure, as you can see in this picture. And then I measured depth with a yardstick, which is on my thank you slide, so there's that. And then I recorded the time with phone stopwatch. My partner dropped the bobber into the stream, and I stood downstream and timed it from the start point to me and recorded the time, which you will see in the results tables here. But as far as methods go, I measured the width in 3 different spots. It was a 29-foot stretch of stream, and in the 3 different spots I measured the width 3 different times. Obviously you took an average in order to have a solid width to do my calculations with, and we did this twice, at the wider section and then the more narrow section. I did the same thing with the depth. I recorded that 3 times at the beginning, middle, and end of the 29-foot stretch and took an average of the depth measurements as well. In the results tables here, you see the 3 different measurements of the width, depth, distance, and time. Obviously the distance remained constant at 29 feet because this was a controlled variable, as well as was the depth. As you can see, it's 1.85 in this and 1.85 in the 1.85 in the first and 1.8 in the second. As you can see, the time is much longer at the first location and much shorter at the second. This was likely because of the width, which was a goal of our experiment, to change the velocity based on the width. And then these are the calculations. The cross-sectional area of the first location was 27.44 square feet, obviously going to be larger than the cross-sectional area of the second at 14.95 square feet. The velocity was 0.13 feet per second at the first location, and that was more than tripled, well, perfectly tripled, quite frankly, at the second location at 0.36 feet per second. One thing that we found was that our discharge was different, which was not intended and not necessarily supposed to be a factor that changes heavily in this experiment. So we do have some guesses as to why that was, but that was one thing that didn't necessarily go correctly with our experiment. So the interpretation of the lab, our goal was met. We meant for the velocity to change, which it did based on the width. The discharge should technically be the same, as I mentioned, as the same stream was being used, but the discharge came out slightly different. This could be due to a tunnel that was in between the 2 sections. However, both sections we thought were far away enough from the tunnel as to where it should not have been affected so heavily. Another factor was there were a lot of ducts at one of the sections, and when they vacated the area, they created their own current, which kind of created a backwards current, which definitely could have swayed the bobber a little bit. And there was also a lot of built-up debris in the first location, lots of leaves, and the rocks and sticks weren't necessarily in the way, but there were a lot of leaves, and the current was not very fast at all in the first location. For future reference, the two different sections of stream would likely produce a better result if they were before or after the tunnel, both of them being before or after, and also assuring a clear pathway with no obstacles for the trial runs. We did have to redo a couple of our trial runs because the bobber got stuck or hit the side of the stream, etc. And then in terms of variables, perhaps changing the discharge rather than the width would show better results, or changing the outcome of the experiment, experimenting with any other variable that would be beneficial, as we could see how other variables are related when different factors are manipulated. So that was my discharge experiment. Thanks for watching my videos all semester. Wish all you guys the best.